So let's start with the first question. A family wishes to accumulate $50,000 in a college education fund at the end of 20 years. If they deposit $1,000 in the fund at the end of each of the first 10 years and another $1,000 plus X in the fund at the end of each of the second 10 years, find X if the fund earns 7% effective. Before that, actually 7% effective means rate of interest. Okay, so first of all, we need to create the timeline diagram which represents the question as usual. So as you can see here, from year 0 to year 10, the family deposits $1,000 each year, while from year 10 to year 20, the family deposits $1,000 plus X dollars per year. So, since we are dealing with the concept of immediate annuity here, so our formula is going to be 1,000 A20 plus XA10 equals to 50,000. Alright, note that if you notice here, I'll assume that the deposit from year 0 to 20 is here. I made it 20 because if you look at the timeline from year 0 to year 20, the family will deposit 1,000. So we can assume that from year 0 to year 20, they maintain their deposits by $1,000. So this is our equation, and then we're just gonna move the terms here. X a to the power of 10 equals to $50,000 minus $1,000 A20, and by that we can solve X by 50,000 minus 1,000 A20 over A10. Alright, if you notice here is actually the formula for accumulative value for n years for immediate annuity. So therefore, we're applying this formula to solve the equation. So we get, at the end, we will get X equals to $651.72. It is advisable that you calculate this separately to avoid miscalculation. So A borrows $20,000 for 8 years and repays the loan with level annual payments at the end of each year. B also borrows $20,000 for 8 years but pays only interest as it is due each year and plans to repay the entire loan at the end of the 8-year period. Both loans carry an effective interest rate of 8.5%. How much more interest will B pay than A pays over the life of the loan? Alright, so first things first, we need to identify the repayment methods of A and B itself. So as you can see here, A is using the method of level annual payments. So therefore, we need to find the level payments, which is denoted by R, first. So our equation is going to be R times with the present value for 8 years in immediate annuity equals to 20,000. So we'll move this to the right hand side. So we will get $1,846.61 for R. Okay, so this is the level of payment for A to pay each year. So therefore we need to find the total payment for 8 years. So therefore we have to divide 8 times 1,846.61 minus with 20,000 because we want to obtain the interest rate that A earned. A has to pay. So therefore we will get 8,372.90. Alright, A is done. For B, it is said that B pays only interest as it due to each year and plans to repay the entire loan at the end of the 8-year period. So therefore, for B, we need to find the interest rate that B paid for each year. So our equation is going to become 0.085, which is 8.5%, times with 20,000 times with 8 years. Therefore, we will get $30,600. So, since the question asks how much more B will pay rather than A, so we'll just have to minus the interest earned from B with A. So therefore, we will get the answer is gonna be 5,771.10 cents. Right. Payments of $100 per quarter are made from June 7 Z through December 7 Z plus 11 inclusive. If the nominal rate of interest convertible quarterly is 6%, so there are 3 sub-questions here. A. Find present value on September 7 Z minus 1. B. Current value on March 7 Z plus 8. And C. Find the accumulated value on June 7 Z plus 12. Alright, firstly, note that do not be confused with the terms of Z. Z is actually a year. So to solve this question easily, we will denote Z, which is year of 2000. Alright, so if you look here, so first we need to create a timeline of all of the transactions or the payments made. So since from all of the questions there are 5 dates total, which is here June 7 Z, December 7, September 7 Z minus 1, March 7 Z plus 8, and also June 7 Z plus 12. So we need to rearrange these dates in a timeline which is like this. So to solve this question easier, we need to make our T in terms of quarter, not year, because since the question said that there are rate of interest convertible quarterly, so therefore we need to solve this question in terms of T in years, in quarters. So therefore here T equal to 0, T equal to 3, here is T equal to 34, T equal to 49, and also T equal to 51. Alright, to calculate the value of T is actually we need to find the range from the first date to the second date and so on. So since 7th September 1999 is the first date, so I'll give you an example on finding T here. So therefore, from 7th September here to 7th June here is actually 3/4 years, which is equivalent to 9 months. So therefore, since we are dealing with quarter here, so we are gonna multiply with 4, so we will get 3 quarters, which is also equivalent to T equal to 3. Now let's move on to the question directly. So for A, find the present value on September 7 Z minus 1, which is actually the question asks for 7 of September 1999. So in this case, to find the present value, since if you look at the timeline here, the payment is actually made at 7th June, not 7th September. But since the question asks for the present value at 7th September, so the first step is we need to extend our timeline payment from here to here for the first question. So therefore, our range of payment is gonna be from T0 to T49 here. So to solve this question, present value in this case is equals to 100 times with present value of 49 minus total present value 2. This is because that we have, after we calculated the whole range of payments, which is from T0 to T49, since we added that we extend our timeline from here to here, so we need to recalculate, we need to deduct the present value that we actually added before. So therefore, that is why here becomes 2, which is actually deduced from T0 to T2, because from T3 the payment of the actual annuity will start. So therefore our formula is going to be like this. So when we calculate, it will become, we will get 3,256.88 cents.
Sorry?
Yeah. For question V, we need to find the current value at March 7, 2008, which is denoted by Z plus 8. So if you look at the timeline here again, 7th March is actually here. So what we need to do is to split, since the payment is from here to here, firstly we will split these two into two parts. So here we will find the accumulation value, and here we will find the total present value. So therefore our solution is gonna be two. So B, we will get the answer of $5,403.15. For question C, the question asks for accumulated value at June 7, 2012. So for question C, the method is quite same as method to solve in question A, but we are going to use in terms of accumulation value, which is AV equals to 100 A. So we will get S 49 minus S, sorry, it's actually 100 times with S angle 49 minus summation of, sorry, S angle of 2, we will get, so we will get the answer of $6,959.37. So the last question, simplify A angle 15 times with 1 plus V to the power of 15 plus V to the power of 30 to one symbol. Okay, so we go straight to the point. So from here we can expand A angle of 15 into this equation, 1 minus V to the power of 15 over I, and then from here we have to expand this term with these three terms, which is with 1 plus V to the power of 15 plus V to the power of 30, and we will get this 1 minus V to the power of 15 over I plus V to the power of 15 minus V to the power of 30 plus V to the power of 30 minus V to the power of 45. So simplify all of this, we will get at the end 1 minus v to the power of 45 over I. So from here we can form our term back into the shortest form, which is A angle 45, using this theory here.